All right, Chris and his sister are walking laps on a track. Chris walks one lap every 4 minutes, and his sister walks one lap every 6 minutes. They start together. And how many minutes will they be together at the starting line again? Oh, my brain's going ding, 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 ding. Do you see the key word? The key word, I do. Up, here's a hint. Remember this? Again. All right, when will they be there again? That's my key word. That's again is LCM, again. So let's look at Chris and his sister. So we've got Chris and we've got his sister. We don't know her name, but we're going to call her sister. All right, now we know that it takes Chris 4 minutes to walk one lap. Well, how long does it take his sister to walk a lap? 6 minutes. Well, what if they wanted to walk 2 laps? Let's kind of separate them to make sure they all get separated. Let's do 2 laps. 2 laps. Well, Chris, how long would it take him to do 2 laps? 8 minutes. You're right. How long would it take his sister to do 2 laps? 12 minutes. Correct. Well, let's do 3 laps. 3 laps. Okay. Well, Chris, it took him 4 minutes to do 1 lap, 8 minutes to do 2 laps. What about 3 laps? That's right. It would be 12 minutes. Well, his sister, for 3 laps, is going to do 6, 12, 18. Well, what are you doing? Each of these are called multiples. They're multiples. So we need to find the least of the common multiples. When will they be at the lap line together at the same time? Well, look at this. 12 and 12. At 12-minute mark, they'll both be at the starting line again. Now, Chris would have done 3 laps, but his sister would have only done 2 laps, but they are still at the starting line together again. So how many minutes will they be together at the starting line again? They will be at the starting line again in 12 minutes. All right, get it down.